Hello everybody. Today I'm going to explain internal structure of timers of 8051 microcontroller. Timers are used to count clock pulses. Timers are used to count clock pulses. So timers clock can be from two different sources. Clock which are counted by timers can be from two different sources. These sources determines application of timers. Timers are used in two applications. One is time delay generator, which which is used in almost all home appliances and in almost all projects. Time delay generator. Take an example of microwave oven. What we do, we set time for heating. Take an example of washing machine. We set spin time. Take an example of air conditioner. We set time. After that, automatically air conditioner turns off. So these are application of timers as time delay generator, and it is also called as timer. Second application is timer is used as counters. Counters are devices which are used to count events. For example, how many person entered in the seminar hall. So here every person generates a clock. The clock represents an event and these events are counted by your timer. So when your timer is used to count events, it is called as counters. It's one more example is in bottle filling system. Whenever bottle is filled, it generates a clock. So clock represents filled bottle and these clocks are counted by timer. So these clocks represents events. And here timers are called as counters. So there are two sources based on which timer applications differ. One source determines timer as time delay generator, other source determines timer as counters. So let us see what are those clock sources. This is the first clock source in which clocks are coming from an oscillator. Oscillator generates continuous clock pulses. So in 8051 microcontroller, crystal oscillator which drives your microcontroller, the same oscillator drives timers also. Same oscillator drives timers also. So oscillator frequency passes through frequency divider which divides this oscillator frequency by 12. What does it mean? If my microcontroller is running at 12 megahertz oscillator frequency, so output of this frequency divider is 12 megahertz divided by 12, 1 megahertz, which means after every 1 microseconds there will be a clock. So here clock is regular. Clock appears at regular interval of time. After every 1 microseconds there is a clock pulse. So when your clock is from a source which generates continuous clock pulses is regular at interval. These clock pulses determines timer as time delay generator. As I given an example, after every 1 microseconds there is a clock. So if my microcontroller counts 100 clock pulses, I can say time passed is 100 microseconds. If it counts 1000 clock pulses, I can say 1 millisecond time has passed. So here clock represents time. So when you want to use your timer as time delay generator, select oscillator as the clock source to drive your timer. So here you can see this is the one source which drives your timer, and second is a clock source in which you can see there is external circuitry which generates clock pulses whenever an event occurs. Its example is like that on a conveyor belt assembly bottles are moving. One side of the conveyor belt there is a light source and other side of the conveyor belt there is a light detector. When there is no bottle between transmitter and receiver, light and light detector, when there is no bottle, light from the light source is falling on the light detector and the output is zero. When there is an obstruction, there is a bottle between transmitter and a receiver, light is cut, no light is falling on the detector, so detector changes its states from low to high. So when there was no bottle, output of detector was low. When there is a bottle, output of detector is high. It constitutes one pulse. So whenever there is a bottle between transmitter and receiver, output goes high and which represents a clock pulse. Here, bottle moving on a conveyor belt assembly is not representing time. It represents an event. When there is a demand, more production is done. When there is less demand, less production is done. There is time when plant is shut down. There is a plant when there is a break. So here clock pulses are not at regular interval of time. Here clock pulses represents an event. So these externally generated clock pulses applied to timers. 8051 microcontroller has two timers called as timer 0 and timer 1. So if I am using timer 0, so T0 which is P3.4 bit 4 of port 3, pin number 14. So these clock pulses are fed to timers through this pin T0 pin. So when your timer is running through clock pulses from T0 pin, your timer is used as counter. For timer 1, T1 pin is there which is P3.5 pin number 15. So I think it is clear now. One is the oscillator which generates timers as which makes timers as time delay generator. Other is external circuitry generating a clock pulse whenever there is an event, makes timer as a counter. Now there is a switch which connects either to an oscillator or to an external circuitry. So when this switch is connected to an oscillator, your timer is used as time delay generator. And when this switch is connected to external circuitry, your timer is used as counter. And this switch is controlled through a bit called C oblique T bar. C oblique T bar. So it clearly indicates that if this bit is 0, timer is used as time delay generator, and when this bit is 1, timer is used as counter. C oblique T bar. C stands for counter, T stands for time delay generator, which is also called as timer. So when you make this bit 0, you are using your timer as time delay generator. It is running from an oscillator, and if you set this bit, you are using your timer as a counter and it is running from pulses through T0 pin for timer 0 and T1 pin for timer 1. Now where is the location of this bit? This bit belongs to TMOD register, timer mode register. There are two timers, so lower nibble of this register is used for timer 0, upper nibble of this register is used for timer 1. So D2 bit controls application of timer 0, D6 bit control application of timer 1. As I already explained, 0 makes it time delay generator, 1 makes it counter. Similarly here also 0 makes it time delay generator and 1 makes it counter. Okay, in case of counter, T0 pin drives your timer 0, and in case of timer 1, T1 pin drives my timer as a counter. So you have to first select your application through C oblique T bar. Now once you have selected an application, your clock pulses arrive up to here, then there is a second switch. There is a second switch. This is on off control of timer. टाइमर को हम कैसे ऑन और ऑफ कर सकते हैं. So this is an AND gate. We have already studied AND gate. AND gate output is 0 if any one of the two input is 0. And when output is 0, switch is open. So no pulse will reach to timer. So we can say that timer is in stop mode. I repeat, if any one of these two bit is 0, output of AND gate is 0, switch is open, no clock is reaching to timer, no counting operation is done. So we can say that timer is in stop mode. So if I want to stop my timer, I will make any one of these two bit equals to 0. And when both the bits are logic 1, output of AND gate is high, switch will be closed, clock will reach to timer, and timer will count your clock pulses. So when switch is closed, timer turns on. And when switch is closed, when output of AND gate is 1. And when output of AND gate is 1, when both its inputs are logic 1. So we have to remember that if both the inputs are logic 1, only then my timer runs. If any one of the two bit is 0, timer stops. Now what are these two bits? T1 pin number 1, which is connected to TR0 bit, timer run bit. This is used to control timer through software. This is used to control timer through software. If I assume that pin number 2 is 1, if I set this bit 1 into 1 is 1, switch is closed, timer runs. If this bit is clear, logic 0, output of AND gate will be 0, switch will be open, timer will be off. So if I assume that pin number 2 is 1, setting this bit turns on timer, clearing this bit turn off timer. Now where is the location of this bit? So this bit belongs to TCON register, timer control register. So TR0 is the D4 bit of TCON register which controls timer 0. D6 bit of TCON register is TR1 which controls timer 1. So this is called software control of your timer. If I have assumed that pin number 2 is 1, so through software control method I can turn on or off my timer. Setting this bit to 1 turns on timer, clearing this bit to 0, clearing this bit turns off timer. Now let us see what is pin number 2. Pin number 2 is hardware control. Through a switch I will control my timer. When the switch is pressed, timer will run. When the switch is released, timer will stop. Here is the diagram. When this switch is pressed, timer will run. When the switch is released, timer will be stopped. Now how it works? So second input of AND gate is output of OR gate. We have already studied OR gate. OR gate, if any one of the two input is high, if any one of the two input is high, output of OR gate is 1. So if any one of the two input is 1, output of OR gate is 1. And when both the inputs are 0, only then the output of OR gate is 0. So if I want to make pin number 2 logic 0, I have to make both these input equal to 0. In that case, output of AND gate will also be 0 and the timer will also be turned off. Now, there are two situations. One is I don't want hardware control. I don't want hardware control. So when I don't want hardware control, I will make second input of AND gate as 1, which means output of AND gate as 1. So how I can make it 1? This is inverter. So if I make gate bit equals to 0, inverter makes it 1. Now this is 1, so irrespective of other input, output of OR gate will also be 1. So output of OR gate will always remain 1. Second input of AND gate will also remain 1s. So this has no effect on the operation of AND gate. So I can control my timer through software method only. So if I don't want to control timer through hardware, I will make gate bit equals to 0. Now where is the gate bit? This is the gate bit. For timer 3, D3 bit is gate bit. For timer 1, D7 bit is gate bit. So if you make gate bit equals to 0, you don't want to control your timer through hardware. Only software controller is permitted. So setting TR bit turns on timer, clearing TR bit turns off timer. So when gate bit is 0, hardware control is disabled. And if gate bit is 1, then what will happen? If gate bit is 1, in that case inverter makes it 0. Now when inverter makes it 0, output of AND gate is controlled through second input. If this input is 0, 0, 0, output is 0. So output of AND gate will also be 0. So when switch is in open condition, this input is logic 0. So 0, 0, OR gate output is 0. AND gate output is also 0. So when I make gate bit equals to 1, and if switch is open, input to AND gate is also 0. So both the inputs are 0. Output of OR gate is 0. Output of invert AND gate is 0. Sorry, input of AND gate is 0. Output of AND gate is also 0. So switch is in open condition, timer is in off position. Now when I press this key, so 5 volt appears across R, which means it appears across the second input of OR gate. So gate bit is 1, so this bit is 0. So 1 logically OR with 0 is 1. In case of OR gate, if any one of the two input is 1, output is 1. Now this is 1. This pin number 2 is 1. If I assume that TR bit is already set because I am controlling through hardware. So I have set TR bit to 1. It has no effect. So if this bit is 1, 1 into 1, AND gate output will be 1, switch will be closed and timer will run. So as long as switch remain pressed, output of AND gate is 1, switch remains pressed, counting operation is done. So switch is controlling my timer. So this is called hardware control of timer. So if I want hardware control of timer, I will set the gate bit. And when switch is pressed, timer runs. And when switch is released, timer stop. So I hope this is clear to you. So this is called software control and hardware control of timer. So gate bit, when it is 0, output of OR gate is always 1. So hardware control is disabled. If gate bit is 1, inverter makes it 0. So pin number 12, which is P3.2 INT 0. So you have to connect switch at INT 2 pin for timer 0 and INT 1 pin INT 1 pin for timer 1. Pin number 13 for timer 1, P3.3 for timer 1. Okay. So this is how we control timer through software and hardware control. Now if I assume that AND gate is 1, switch is closed, timer is counting clock pulses. Now how the counting is done? Counting is required count registers. Now both the timers are 16-bit timers. Both the timers are 16-bit timers. As we have already studied, 8051 microcontroller is 8-bit microcontroller. So 16-bit timer, how does it how 16-bit register is accessed? So two registers are grouped together. There is no one 16-bit register. Two 8-bit register, timer lower byte, timer higher byte, TL, TH. 0 stands for timer 0 register and 1 stands for timer 1 register. So TL0, TH0, these two registers are grouped together to form a 16-bit register. So we write either in TL or TH. We can't write in both the register at one instead of time. So this is how 16-bit register is formed. It is a group of two 8-bit registers. Whenever TL0 will overflow, what is the maximum value? FFH. After that, this TL will roll back to 0 and a carry will be generated. This carry will increment TH0. So whenever TL0 will overflow, TH0 will be incremented by 1, and this will be done by 8051 architecture, hardware of 8051. We don't have to do that. This is a 16-bit register, two 8-bit register grouped together. So what is the maximum count? Maximum count is FF FFH. So 16-bit maximum count value is FF FFH. After that, timer will overflow. TL0 will become 00. It will generate a carry. That carry will also make TH equals to 00 and carry will be generated. This carry will be stored in TF0 flag, timer overflow flag. TF0 timer overflow flag for timer 0, TF1 timer overflow flag for timer 1. So where are the location of these two flags? These two flags belongs to TCON register. So TF0 timer overflow flag for timer 0, TF1 timer overflow flag for timer 1. So D5 bit and D7 bit of TCON register are used as TF0 and TF1 flags. So whenever timer overflow, which is an indicating that counting is over, TF0 flag is set. So we keep monitoring TF0. As long as timer is running, this flag remains 0, and as soon as timer overflow, this flag is set. Now suppose I want to count 100 clocks. I want to count 100 clocks. So both the timers, timer 0 and timer 1, both the timers are up timers. They do not count in downwards direction. We cannot start from 100, 99, 98, 97, 96. This is called down counting. Both the timers are up counter. So if I want to count 100 clocks, I will return back 100 steps from maximum count. So what is the maximum count? FFH, which is 65,535 in case of decimal. So 65,535 minus 100, it will be 65,435. So this will be the starting value of my count register. So my counting will begin from 65,435. So after 100 clock, it will become 65,535. And 101th clock will cause it to overflow. So I have counted how many clocks? 101 clock. This one clock is eliminated by adding 1 to our starting value of count. So final equation will be 65,535 minus 100 plus 1. So I will start my counting from 65,436, so that after 99 clock count will reach to 65,535 and 100 clock will cause it to overflow and TF flag will set. So that was all about internal structure of timer, operation of timers, and we have seen different SFRs associated with timer, TMOD register, TCON register. In TCON register there are 4 bits: TR0, TR1, TF0, TF1. In TMOD register, C oblique T bar which controls application, gate bit which controls the hardware or software control. Now there are 2 more bits in TMOD register which determines the mode of operation of timer. M0, M1. 00 means mode 0, 01 means mode 1, 10 is mode 2, 11 is mode 3. What is mode 0? In mode 0, out of 16 bit, only 13 bits are operational. So timer is used as 13-bit timer. So as a result, its maximum value is 8191 pulses. 8191 pulses. This is the maximum bit. This is the maximum count. So if I am using my timer in mode 0 and I want to count 100 clock pulses, so I will use maximum count as 8191 minus 100. So maximum count in mode 0 is 13-bit mode 8191. In hexadecimal it is 1FFFFH. Now what is mode 1? Mode 1 is 16-bit mode of operation which I have already explained. Maximum count is 65,535. So if I am using mode 1, all 16-bit are operational. Maximum count is 65,535. Mode 2, timer is used in 8-bit auto reload mode. Timer is used in 8-bit auto reload mode. So here maximum count is 2 raised to 8, which is 256, minus 1, which is 255. So if I want to count 100 clocks, I will subtract from 255. 255 minus 100, which is 155, plus 1, which is 156. This will be the starting value of count. Now it is auto reload. What is auto reload? I want to count 2 times. So in case of mode 0 and mode 1, when timer overflow, count register value becomes 00. So in case of mode 0 and mode 1, I have to rewrite the initial value. 65,436 I have to rewrite. I will store this value somewhere in the memory. From there I will transfer it to TL0 and TH0. So this is called rewrite of value. After every operation, whenever timer will overflow, to start timer from its initial value, I will write the initial value in count register TL0 and TH0. But in case of 8-bit auto reload mode, my starting value 156 is already there in TH register. So whenever TL0 rollovers to 0, TH0 content is automatically transferred to TL and counting restart. So here you don't have to rewrite your value in TL register. Whenever timer will overflow, whenever TF flag will set, TH value will be automatically transferred to TL and your counting will again start from the initial value. So this is called auto reload. This is possible in 8-bit mode because one register holds the copy of initial value. Not possible in 13-bit mode and 16-bit mode because both the registers are used for count values. And last is mode 3, split mode. In split mode, TL0 will be used as count register for timer 0. TH0 will be used as count register for timer 1. So TL0 is 8-bit timer for timer 0. TH0 is 8-bit timer for timer 1. And the count register of timer 1 can be used for general purpose operation. So this is called split mode. So that was all about the operation of timers. So there are two SFRs, T-mod register, T-con register, through which we control timer. Okay. So T-mod register, lower nibble is used for timer 0, upper nibble is used for timer 1. Timer operates in four modes. Mode 0 is 13-bit mode, mode 1 is 16-bit mode, mode 2 is 8-bit mode, and mode 3 is split mode. C/T bar controls the application. Gate bit controls the hardware control. Okay, in case of T-con register, TR0 is start bit. When it is set, timer runs. When it is clear, timer stops. TF0 is overflow bit. Whenever timer 0 will overflow, TF0 will set. And whenever timer 1 will overflow, TF1 will set. And in case of hardware control, when gate bit is 1, you want to control hardware. So input is switch is connected to INT 0 bar for timer 0, INT 1 bar for timer 1. Okay, P3.2, P3.3 bit. So that was all about timer internal structure and its SFRs. In next lecture, inshallah, we will see programming on timers. We will write programs to control timers. So in next lecture, we will develop C program to control timer. Okay, thank you very much. If you like this lecture, share to your friends also, and don't forget to press like button and subscribe to my channel so that whenever I load new video, you will be updated. So thank you a lot.